Good evening, ladies and gentlemen, and welcome to today's LIDNUG event with John Robbins. And tonight's topic is taking a break in the debugger. As always, we would like to thank our sponsors who, without your support, we can't carry on doing what we do. So thank you to Orksweb, Telerik, Innerworking, Syncfusion, Pluralsight, Wintellect now. If you want to find out more about us, we are available through a number of sources. Of course, you'll find us on LinkedIn. If you search out for our group there, that's the best place to go. We also have a presence on Twitter, Facebook, and all our videos, our back catalogue is posted to YouTube as soon as we can get them on there. Towards the end of May, we also have another event with Wintellect on getting Visual Studio ready for TypeScript, Visual Studio Code rather. So I hope to see you there. For more events, if you just go to Eventbrite there, LIDNUG events at eventbrite.com, you can keep a track of what else we have going on. As I said, tonight we have John Robbins with us, who's a co-founder of Wintellect. You can find him on Twitter, and he is known to be the connoisseur of software bugs. And also, if you go to Wintellect.com, you'll find a lot of blog postings from John Robbins as well as the other members of the Wintellect team. And when I got a quick look earlier, there's 290 odd from John Robbins himself, and going right back to 2004. I'd wholeheartedly recommend that you do visit it if you haven't yet. It's an excellent source of wisdom and guides and just general pointers. But it's definitely worth a look. If you have a question to ask, you go to the Q&A tab at the top there. The system allows only one question at a time from each person. But if you drop it in there, either I'll pick it up if it's not related to what John is talking about, or if we just allow John to answer questions and we'll take his lead on that one when he wants to do so. At the moment, I'm the only member of LIDNUG in the list, but if you find me, I'll be with the LIDNUG in the square brackets there, just next to my name. If you just double click on me, you can send me a private message if you need my help with anything. Attended geography, he was quite well spaced over the globe there, right from Australia to the west coast of America. So without any further ado, I'll give the floor to you, John.
Well, thank you very much. It's great to be back to LIDNUG presenting again. It's pretty interesting that, just the wide range of the world with these presentations. So I'm very honored that many of you are staying up late at night to listen to this and to talk about taking a break in the debugger. And I appreciate it very much. So if you have any questions whatsoever, do not hesitate to ask them in the question window. I'm going to start sharing my desktop now. So you should see everything. So if you've got a question, please feel free to interrupt me because, if you need me to repeat something, because I know we've got folks from all over the place, I'll be happy to repeat it and try to keep up. But it's really exciting to be here with the LIDNUG group because you guys are all letting me do something I have always wanted to do, and thank you very much for this. I've always wanted to present naked. And I'm doing it now. Notice I don't have my webcam on. I just scared everybody. So what we're going to talk about today, now that I've scared you all to death, is taking a break in the debugger. And that's using this wonderful Visual Studio 2015 debugger to program it, to make the debugger stop when you want it to stop. And we're going to cover a broad range of things here, because I know most of you have never read the Visual Studio documentation. But I want to show you a lot of tricks and techniques that you can use to solve some really interesting problems using the debugger with breakpoints, with the expression evaluator. So we're going to really talk about that day-to-day debugging. If you have any questions between now and the end of time, anything related to debugging, software development, pretty much anything except relationship problems, I'm not going to help you with those, but anything else, I'll give it a shot. Email me, john@wintellect.com, or DM me on Twitter, @JohnWintellect, because I want your feedback. I want your emails, because how do you think I learned about what's going on? I learned from your questions and the pain that you're experiencing. So we'll be glad to help. And, if I don't know the answer at Wintellect, somebody else at Wintellect probably does, so we can bring a bunch of folks in and try to get your questions answered, because it's just a great way to learn things. So I do have one thing I do want to mention here real quick, and that is that I want to give you guys Wintellect's on-demand, Wintellect Now, our on-demand video training solution. And if you, so Jonathan's requesting control. No, I'm not going to let you control my machine, Jonathan. Nice try. But if you use this code up here, John R20-2016, what we'll do is it will give you 2 weeks free of all videos, and that includes my 20-plus hours on debugging, another 4 or 5 hours on performance tuning, plus 350 other sessions that we have up there. So feel free to take advantage of that. If you have ideas for presentations that need to be there, why don't you propose it? Maybe we'll pay you to do one. But this way you can get a lot of good training at a pretty good rate, because it's free for the first 2 weeks. Now, I hope you don't mind, but this is the last PowerPoint slide I have. I know you really want me to spend my time in PowerPoint, but I'm not going to, because I wanted to do nothing but demos here. Because, well, we're software developers. We want to get those things done. So I'm debugging a real simple little application here. Right? This is not the greatest UI you've ever seen. But what we're going to start talking about is setting some breakpoints, right? You've all gone into a source file and set breakpoints before, so I'm not going to start with that. We're going to concentrate on the stuff that's kind of unique to debugging. So let me, I forgot to do the present on here. Hold on a second. Let's get this so we can, there we go. It's some bigger fonts here for everybody so you can see what's going on. And so what we're going to start with first is just different ways to set breakpoints that you probably didn't realize that you had. So the first of these I want to talk about is kind of an interesting scenario. So you've got this scenario where you've got a breakpoint and you've got a deep call stack, okay? And we're going to go into this deep call stack, and if we look at the call stack window here, right, I want to stop when a particular scenario occurred, and I hit that. And I want to stop, and I want to go back to where this method got called. And you'll want to stop on the return. So what I'll see people do is that they'll set the breakpoint there, but what's the problem? Right? Breakpoints execute before the line of code, right? So it stops you. So are we going to stop when this returns? Unfortunately not. We're not going to stop at all, because we're going to be stopped when x.do is called. So let's clear that out and go back to where we were. Let me show you the neat thing you can do here in the call stack window. If you want to stop on a return address, all you have to do is highlight that line in the call stack window and simply press F9. And notice a nice little red circle showed up down there. And if we go look at the breakpoints window, you'll see, if we expand this out, that, oh wow, we've got a huge hexadecimal number, right? So this set a breakpoint on the return address from the call stack window. So when I press F5 now, we're going to stop back where we wanted to stop. So that's just one of those cases where, especially with a lot of async code, a lot of recursive code, I want to stop when this returns, use the call stack window to set that up. So that's a pretty neat little thing. Now, another thing you can do when setting breakpoints, and a good example is this for loop here. If I set a breakpoint on line 35, right, that's just the first part of the for loop. There's nothing else there. So how many times is this going to execute? It's going to execute once. Well, how many executable statements do I have on this line of code? Well, it's a little tricky because I used the comma operator to mess you up, but I actually have 3 executable statements because in .NET, that's what the semicolon delineates. So if I've got multiple statements on a single line, .NET supports sub-expression breakpoints. So I've put the cursor on the comparing section of the for loop, and I can press F9, and I can then go to like the incrementer section and press F9. In fact, with Visual Studio 2015 and .NET 4.61, they even let you do the individual statements with the comma operator. right? That's a change from Visual Studio 2013, so it's kind of interesting. But if we go back and look at the breakpoints window, you can see that I have multiple breakpoints on the line because the character is included as well. So if you've got multiple expressions on the line, don't be afraid to set multiple breakpoints on them. Now, since I've set those breakpoints, oh, by the way, how do you know which one got hit? Let's do that part of the loop. Okay. So we can see that, right? The bold characters indicate that's the one that got hit. Now, here's the trick, though. What's going to happen when I click the circle here, or click the red circle to clear the breakpoint? Which one is it going to clear? Well, unfortunately, it clears them in character order, right? It just looks, oh, that's the first character, line 10, or character 10, then 15, then 30. It's going to clear them in that order. So if you've got multiple breakpoints multiple expressions on the line, it's very easy to set breakpoints. Now, my job at Wintellect is to debug other people's applications for a living, right? How cool is that, right? Nobody calls me up and says, hey, John, can you fly halfway around the world because we have this null reference exception that we can't figure out? Can you type equal new object for us? Right? People don't call me up with simple things. They call me up with impossible things. And so I sit down. I don't know your business. I don't know your code. So somebody else is driving the machine. And so I'll say, ooh, that's an interesting looking method. Let's go set a breakpoint on it. And what do people do? They scroll, and they scroll, and they scroll for half an hour just to go, just to set a breakpoint on a method. Well, if you know the name of the class and method, you don't have to scroll around for it, right? All you have to do is go to our friend the debug menu, then new breakpoint, break it function. Okay? This is awesome. Because with break it function, it brings up this dialog, and you get to type in the name of the class and method. And you know, I've got like the lot up there, so we'll set a breakpoint on that. Notice we can also apply conditions and actions. We'll talk more about those. And boom, it set a breakpoint for us. So if you know the name of the class and method, you don't have to go hunt it down. You can just type it in the new break it function menu. So, or the function breakpoint menu. So let's go show something else here. So you can see I've got T, right? There's my method T. Well, if I want to come up here, new breakpoint, break it function, all I have to do is type in the name. I don't even need the class. And I can press OK. And what's going to happen? It's going to set the breakpoint, right? The cursor doesn't have to be there. Now, some of you are thinking, well, John, that is really cool, but what happens if I have an overloaded method? Well, I just so happen to have two methods that are overloaded. So let's find out what happens. Let's go to, I'll put the cursor up here just to show you, break it function. And I've got those two methods called overload. So what's going to happen? Center. Sets a breakpoint on all of them. So this works across your project. That if you've got the execution point there, you can set a breakpoint on it. Now, so this is a very cool thing because if you know the name of the class and method, if you know the method name, you can set it. Now, one thing that this doesn't do, I go back to this, is I'm not able to do things like this. I can't do D star. Right? I can't use wildcards or regexes here. Another thing that I can't do is I can't do class.star. Interestingly enough, if you're still doing C++, you can do class : star, and that sets a breakpoint on every method, only in C++ code. Now, let's talk about that for a minute. Why would you want to set a breakpoint on every method in the class? Well, testing. Right? That's why I use it all the time, because if I've got a breakpoint on every method in the class, I can do that exploratory testing, I can just do that play testing, and every time I hit a breakpoint, I clear it, then I can keep an eye on the class and say, wow, I missed these three methods. Those methods didn't get called. And this is just a great way to test and look and learn who's calling what in your code. But we don't have a way to do that in .NET, so it's kind of frustrating. So what I did is I wanted to fix that, And if you look at Visual Studio, they no longer have off the tools menu. They've removed this a couple of releases ago. We no longer have a macros menu. So back a few years ago, I had written some macros that would set a breakpoint on every method in the class. Well, we don't have macros anymore because I guess easy extensibility is not what Microsoft wants us to do with Visual Studio, which is kind of frustrating to me. So I asked them about this. I said, well, I've got a whole bunch of these 4- and 5-line macros that help me debug. What am I supposed to do now? They said, oh, it's really simple. You're going to download a 250 megabyte SDK. Then you're going to install the SDK, and then you're going to write an add-in to Visual Studio. And I was like, these are like 4-line macros. Why do I want to write a whole add-in for something that simple? So I got a little frustrated by that. And if you go to can't type today, code.wintellect.com, you'll get to our GitHub pages. And on our GitHub page is this really cool set of PowerShell macros that plug into Visual Studio. Because I realized that in the package manager, what do you have here? You've got PowerShell. And I like PowerShell. And I noticed that the Package Manager console, because it plugs in PowerShell, gives us access to $DTE. And if you're familiar with writing add-ins, that is the root of all automation inside Visual Studio. The Development Tools Environment is what that stands for. So if you can get access to the DTE, you've got access to everything. So what I did is I ported all of my macros over to this PowerShell module. So these work through all versions of Visual Studio from 2012 to 2015, and they let you do a bunch of neat things. So let's go take a look, and being just a standard PowerShell module, you just do an import module on this, right? This is straight PowerShell. I have my PowerShell profile automatically loading this. Let me clear out all the breakpoints. Okay. So if you do want to set breakpoints on all the methods that are in a class, sometimes the tab doesn't work real well, and it just decided it didn't want to work. So I've got this commandlet, add breakpoints on all doc methods. What that will do is it looks at the current, oh, there the tab decided to work. So the tab Package Manager console is not the fastest in the world. So anyway, what this will do is it looks at what file is currently active and showing, and when you run that, what did it do? It just ran down and set a breakpoint on every single method in that class. So now I can run this code and go, oh, okay, where are all the spots that these methods get called? And I can, just run through and I clear them, and I get a pretty good idea of what code didn't get covered because I can keep an eye on it in this breakpoints window. So this is pretty cool because it lets us get that function coverage basically. But notice I'm going to set some other breakpoints in here. So I'm done. So what can I do? I can do remove breakpoints on all doc methods. And what does that do? That removes any of the breakpoints that I had set previously. But it does not remove any ones that you set manually. So between those two, I do a lot of testing with this, right? Who's calling this method? Well, it's really easy to find out because you've got to, quickly and in batch set breakpoints. And if you've always wanted to be able to set breakpoints with regexes and stuff like that, why don't you take a look at this code? It's all a simple little module here that does the work, that just lifts it up so it makes it really easy to figure out. And I've got a bunch of other methods in here. You can look at the help on this to see more about it, about invoking WinDebug, clearing out IntelliTrace logs, that kind of stuff. So there's a lot of cool stuff in here just related to debugging. So that's one form of automation. So great, right? We've been talking for about 15 minutes, and all I've really done is shown you how to set a breakpoint. So let's make a breakpoint smart. And something I want everyone to realize, and let's talk about the theory of debugging, right? When you have a problem, right, a lot of people say, well, let's jump into debugger, but the debugger is actually the last resort. You want to sit down and think first, right? Because if you're thinking, you're solving the problem. Because black holes exist, and they exist on the face of the earth, and it's called the debugger. Because how many of you have started the debugger, and then you spend, till 2 in the morning, and you didn't get anywhere, and you're like, wow, when did it become 2 in the morning? So you want to be smart about this, and every time you want to use one of the advanced features of the debugger, these location breakpoint modifiers, which we're about to talk about, you want to be smart about it. You want to push that thinking so that you have that hypothesis written down. I want to stop when, because now you're going to program the debugger to match that hypothesis, okay? So let's look at some of these modifiers. And I'm going to page up a little bit here. And I'm going to set a bookmark because we're going to come back to this loop a lot. So the first of the location breakpoint modifiers I want to talk about here is simply enough the hit count modifier. And this is a condition that allows us to do when it's equal, multiple of, think modulo, right, every 5th time, or greater than or equal to a count. This count for this hit count is a 1-base count. So all of you that are C# developers just got screwed up, okay, but it's a 1-base count. So we can do a hit count equal, let's do multiple of, let's say 3, okay? And there we go. We've got it set. And oh, by the way, you can see that this is an advanced breakpoint because Switzerland shows up over here, right? Because we all know the Swiss are advanced. So that's pretty cool. So we'll go ahead and run, and let's do our big loop. And just to prove this to you, we will go over to our locals window, and you can see that I started at 0, and hey, great, now it's skipped the first couple of iterations. So the hit count allows you to execute this point for a specific number of times. So it's very powerful and a very unique thing that the debugger gives us. But wait, there's more. Okay, there's something really cool with this. Let me execute it again. If I go over to the breakpoints here, I want to show you what I think is something very cool, and that's the hit count. So every time you actually hit this breakpoint and then continue, because the counter didn't match, right? In our case, modulo, multiple of, but if your counter doesn't match, you get to see how many times it executed that location. So let's talk about 2 places where that's kind of interesting. The first, for each, right? You've got that wonderful for each loop in C# or VB. But what's the problem, right? You're working or enumerating across some link statement, and you have this exception, but you're like, wait, this collection's got 250,000 items in it. Which one is bad? Well, do you want to sit here and then expand out all of these, right? That's well, if you're paid by the hour, that's awesome, an awesome way to make money, okay? But, really, that's not such a good way to go. You want to know which one it is. So if you think you've got a partially duplicatable case, what I do is I go set that hit count to some gigantic number. It's an unsigned integer, 64 or 32-bit, so it'll go up to 4 billion. Then run the application again, and then when you crash, what are you going to have on this hit count? You're going to have how many times that line executed, and that's going to give you an idea inside that for each loop how many times you executed. So it throws in an index on the fly. So that's pretty darn cool if you ask me. I like that a lot. Now another thing, in fact, I'm going to have to draw a picture here. So let's do this. So I've got this theory of debugging, right? Maybe if I win the lottery and go back and go get my PhD in computer science, but I've got this theory. Where are all the bugs in your code? Okay, so we've got the bug count is down here on our x-axis, right? And on our y-axis is the execution count. How many times did it execute, right? And it executed from 0 to infinity. And the bug count is 0 to infinity as well, right? So my theory is this, that if the execution counts and the bugs look like this, right, that's where the bugs are. It's in the areas that executed very little. Oops, I got these backwards. I'm sorry. That's the execution. This is why I can't have a PhD, and this is the bug count. There we go. So my theory is that all the bugs are in two places in the code. The place where it executes very little and the place where it executes all the time. And why is this, right? If it's the part that executes very little, what's the problem? It hasn't been tested, right? That's the big thing, right? You know, you're according to Steve McConnell in Code Complete Second Edition, your average unit test only executes half the code. So that means half the application from the unit test standpoint hasn't been executed. Probably your integration tests aren't much better. So that means half your app is waiting to crash. So the part that didn't get executed very much has a lot of high bugs. And of course, the other side is you have a lot of bugs where it executes all the time. Because what is that? That is where you've got the off by one errors and things like that. So when I'm handed 30 gigabytes of source code and I want to figure out where are the bugs, I set a whole bunch of hit counts with very high numbers, and that helps me narrow down where I'm going to go read the code. Because that's the fastest way to debug. It's not using a debugger. You use the debugger to help narrow down where it is that you want to spend your time looking. So this hit count modifier is a really cool thing that lets us really see that, you know, a lot of interesting things because it keeps track of how many times this thing was actually executed. So that's a very cool part and a very cool thing that Visual Studio gives you. Now, the other type of breakpoint and modifier that we have here, which is pretty darn cool, is a, so let's zip past this. We'll set another breakpoint here. And the next type of breakpoint we want to do is the one you're going to use the most, which is the conditional expression. And this is where you can evaluate an expression, okay, or as when changed. So, you know, for the example there is x equal to 5. Well, if that's true, you're going to stop. But you can also do a when changed here. So I could do something like this. I could do conditional. Notice you got full IntelliSense here because they want you to do this. So this would mark the first time through this loop. It would say, what value does I have? Well, I is 0. Great. So it stores that in the debugger, says this is what I saw. Then the next time it hits this breakpoint, it says, is I different from what I stored before? It's different, then it would break. So you can monitor variables with this. But you do have to execute the location. Keep that in mind. And the other one you can do is when true, which is mostly what you're going to do, where you're going to do things like this, where I equal 3. Okay, so there we've set a conditional on it. You can see that we've got the conditional because, you know, hey, Switzerland is there again. In fact, you can even see it in the tooltip when you go look at a tooltip to see things. So let's execute through here, and we'll come back. We'll do our big loop, and sure enough, I is equal to 3. So this is kind of an interesting breakpoint here because the fact that we can evaluate something opens up some pretty interesting thought process here. So if I can evaluate a conditional like that, I equal 3, can I do something bigger, right? Can I go in here and say, do a thing what I call assertions on the fly? Can I create a method that returns true if there's a problem? So say, for example, right, this is a very simple example, but you'll get the idea. If you have this class, you know what its referential integrity should be, right? If this value, if this member field is this and that member field is that, you know, you have an idea if it's referentially correct. Well, how about writing a method that checks that for you, right? Notice I've got that check name there. I want you to look very closely. Oops, look very closely. Notice I have it set to private. Keep that in mind. So I've got this method. It's a private method. But what can I do with it? Well, let's go back over here to our example. And you can see my examples right there. So I'm going to set my breakpoint. Right, go to my condition. And I'm going to type a dot. Hey, the IntelliSense is here. They want us to do this. But notice my method isn't here. Right? Why is that? Well, what is the difference between public, private, and protected as far as the debugger is concerned? There is no difference. Everything is public to the debugger. But the IntelliSense control, rightfully so, is only showing you the public methods. And if you're going to create these special methods that read memory and check state, you want those to be private because you don't want people to accidentally call those. So what we can do here is I can go back, right? So I've got that check name. Anytime I want to, oops, let's get this back. And how do you call a method? Just put parentheses on it. If that method takes parameters, fine. No problem at all. You can do that. So great, we've got that saved. Wow, Visual Studio just decided to get weird. And I'm going to set another one down here because you can see that I'm setting that name parameter to null. So let's go to this condition, and I'll just paste it in. So we are good to go. So you got our two advanced breakpoints there that are calling a method. So I'm going to go ahead and run this, and you can see that name gets set to null in the middle, and boom, we stop. So this is where we can use the debugger to do some work for us, right? To do that manual checking of state, right? Throw in that private method, and boom, now you can call it from the debugger. So here's the quiz question for you. Where did this execute? Because obviously, you see we stopped, so something had to call this method. Where did it execute? Did it execute in the debuggee, the program you're debugging? Did it execute in the debugger? Anybody have any idea? How about Bill Gates' machine, maybe? Yeah. It executed somewhere. Well, with Visual Studio 2013 Update 2 and higher, which obviously includes Visual Studio 2015, these execute in the debugger. Okay? Think about that. So the analysis is actually happening in Visual Studio. It's not in your process. So what does that mean? Well, if we go back here and we go to our condition, by executing in the debugger, what do you think that would do, right? C#, that's an assignment. So let's see what happens since this executes in the debugger, because if you look at this loop, right, it's looking for I to be over a specific value. Oops, let's edit that. It's I, not X. So I equal 3. So if this changes memory, let's see an infinite loop here because I will never get to 10. Well, let's look and see what happens. Aha! Okay? So these methods you call from the debugger, from breakpoints like this, can only read memory. They cannot change memory, right? By me trying to set I equal to 3, that's why we get this error. Okay? So you can only read memory with these. And that's a little bit of a change because, you know, in older versions of Visual Studio, you used to be able to execute these in the debuggee, okay? And that's, you know, there's times you want to do that. Not many, but, you know, there's times where, gosh, when I get in here, I want to force this data into this variable here so I can duplicate some very hard to reproduce condition, right, using the debugger as a testing tool. So let's talk about how we can turn that back on. So I'm going to stop debugging, and I'm going to go into the options dialog for the debugger. Well, down here at the bottom, it's use manage compatibility mode, okay? So if you want that method that changes memory to work, you have to turn this on. Okay, so I've turned that on, use manage compatibility mode. Now watch what happens when we re-execute, right? Start debugging with this. So I'm going to do my big loop. Doesn't look like anything happened there, but if we look at the output window, what do you see? We changed memory. Okay, so we still have that way that we can change the state from the breakpoint. And, you know, the 2 or 3 times a year you need this pretty bad. So that's why they left the managed compatibility mode in there. But the default is that this is read-only, okay? You can read memory. And, you know, that's, in most cases, that's what you want, because you want little tiny methods like this that check your state so you don't have to do it manually. So let me go back in and turn that off so everything else works the way we want it to, right? But that's the only time you really need the managed compatibility mode, right? Is that way right there. So that's pretty cool, right? You know, we can set these complicated conditions that do all sorts of interesting things, that call methods that, you know, even if we change the compatibility mode, can change the state. So we've got a lot of cool stuff here with that condition, right? So that's the one you're going to use the most, and the one that offers a lot of interesting possibilities. Now let's talk about a little bit. Let's clear out all these breakpoints. And the next style of breakpoint we want to talk about is a filter breakpoint. This is where we're going to talk about multi-threaded debugging. So my application here has a button on it that will create threads, right? So that fired up a whole bunch of threads, and you can see in the output window there that they're starting up. Well, if I go look at my threads window, I've got nothing in it. Because unlike the output window or the debugger's module window, by the way, just to make sure everybody knows, you can find all of these windows I'm talking about off the Debug Windows menu. And so can update live, like this modules window can update live, processes can update live, but the threads doesn't. And why is that? Because the overhead of updating this window, right? Think about your async calls, right? Your threads are transient, right? Your thread may only run for 1/10 of a second. And if they updated this window, it would just kill performance. Excuse me. So if we want to look at the threads window, we have to break in the debugger. So we've broken in. Now, when we stop, all of the windows are updated. That's pretty cool. Well, let's go and play with this. Let's go set some filter breakpoints. So all of these are at the same spot. They're all waiting on some handle there. And they're all doing this a little stupid thread here, right, which is just basically blocking. And so we want to stop only on a specific thread. Well, if I go over here and set a breakpoint, which thread is it going to stop on when I signal that wait event? Because, you know, all of them are here at that super duper threader. You can see that in the function there. Well, all of them would stop, right? Because breakpoints are global to all threads. So if I want to filter this down, right, I can go here and I can go to my condition and I can choose a filter. And this filter, notice it lets me set my machine name, process ID, process name, thread ID, and thread name. And so, you know, if we're doing remote debugging with multiple machines, you can even narrow it down to an individual machine. So I'm going to choose thread ID equal, and I'm feeling 23020 because that's my thread ID that I picked out right here. Okay? So there we go. We've got our filter set. You can see that in the pop-up there. And so if I did this correctly, when I press F5, and then I close my threads, which signals that event, if I've done my job right, there we've stopped on thread 23020. So the filter is pretty cool for, you know, narrowing down. I want to follow this particular thread, so I want to add that filter to the breakpoints. That's, you know, that's kind of cool, and it works. But does anybody really kind of see the problem with this? Well, it's not really a problem. It's just the design of the debugger. Right? You know, so the debugger, the design here assumes you know what thread you're running on. And that was fine back in the days when everybody managed their own threads, right? They, thread variable X equals new thread, X dot start, you know, right? You did your own threads, but what are you using today? Well, you're using async. You're using the thread pool. So, you know, one of the things that we have here is that we don't really have a good way of saying, well, when this particular code runs, I don't know what thread it's going to run on. So we can't, you know, this only is an after-the-fact breakpoint. So a very common question I get is, hey, John, I need some way to identify an object so that I can set breakpoints only on a particular object. So let me show you what you can do here. and we'll go get my assert example. So for a lot of async code, okay, by the way, I've turned off edit and continue, so I have to stop debugging. So let's pretend this is used in an async manner. So what I'm going to do here is I'm going to create an ID. Okay, that seems pretty simple. But I want to make sure that that ID is completely unique across all instances. Okay? So what am I going to do? Okay. We have to create another static. And what we're going to do down here is, well, we're going to take advantage of one of the coolest classes in .NET, right? And which wraps a lot of Win32 coolness. So I want to make this unique. So I'm going to use the interlocked class. And this is the class you use because it's synchronization. I had to stop for a minute to think how to say this. It requires no synchronization. So think about it for a minute. You've got all of these methods here that allow you to do particular operations with zero synchronization, and I should say software synchronization. So what you do is that you take advantage of this interlock increment here, and what's that going to do? That's going to return a unique value like that. And it's guaranteed to be unique because this uses hardware synchronization. And so this is blazingly fast and doesn't have essentially no overhead in the big scheme of things. And now we've guaranteed that every time one of these assert example classes is implemented, guess what? Its ID is going to be a unique value. So as I'm looking at execution and I see, okay, I'm looking at this particular object, it's got an ID of 1,537. Now I can set breakpoints using conditionals, this dot IID equal 1537. And then I would break no matter what thread was executing that on that one particular thread. Okay? So this is how you're going to deal with your async code. And especially if you're writing the class library, stuff that's using async code, put something like this in the base class so that everybody benefits from it. And that way, anybody deriving and using your class library, they would automatically have a unique ID assigned to that particular object. So that's how you're going to deal with that async code. Okay? So I'll just undo all of that. Sure my build still works. But let's get back to our multiple threads now. Back to our filter breakpoint. Yeah, how do I break an async code? That's the most common question I get, because we don't have any a priori knowledge of what's going on in those threads. So let's create a bunch of threads, and let's talk about something kind of interesting that else we can do with these thread breakpoints. So when I was setting that filter, another thing we can do here, is when I set the filter, notice I can set it on thread name. So how do I set a thread name? The only way to set the thread name is here in the window, where you're going to right click and, well, rename. And we'll call this one, right? So we'll stop for Bill Gates. So now if I set this with this condition of a filter, thread name, okay. That's how you can use the thread name. Now, some of you that have been doing .NET for a while might go, wait a minute, I thought the thread object had a name field on it. Can I set this in my code? And the answer is no, because there's a major bug with the thread name property in that it can be only set once. Because the way the code is written, and they can't fix it for backwards compatibility problems, if you set the thread name, the next time somebody comes through and tries to set the thread name, that throws an invalid operation exception. Okay? I've asked for this bug to be fixed, but there's a whole backwards compatibility story with it, so they can't fix it. So it's kind of a very large pain in the butt. So this is the only way that you can set a per thread name, is by doing it from the debugger. And another question I get related to these thread names is, well, let's say I rename this thread to interesting thread. And what happens if all of a sudden I realize, wait a minute, I've got 2 threads that are interesting. What's going to happen here, right? What happens if I rename 2 threads to interesting thread? Nothing. You can name all threads interesting threads. So that's how you can get your thread name in there. So it's kind of a cool thing to do with our filter breakpoint. Now, since we're talking about multi-threaded debugging, let's talk about some fun. How many of you haven't totally enjoyed this situation where you're debugging along, you're single-stepping, boom, all of a sudden you end up in a completely different thread and you're single-stepping God knows where. Don't you love that? Now, why does that happen? What's causing that massive bounce to another thread? Well, you might not realize this, but to be a developer on the debugger team at Microsoft, you have to have a PhD in artificial intelligence. Because when this debugger is running, it has a neural network brain scanner in it that figures out when you're within 22 seconds of solving the bug, that it randomly jumps to another thread, so you spend more time in the debugger. That almost seems reasonable, doesn't it? That's kind of crazy. But the real thing that's happening is not the brain-reading neural network. What's really happening is that you're single-stepping a thread, and then what happens? That thread either does one of 2 things. It blocks, right, because it does an I/O operation, or it uses its quantum. If you read the book Windows and Terminals by Solomon Rusinovich and Ionescu, you'll read about this quantum, and that's the 15.6 milliseconds that every thread gets to execute. Right? That's all the operating system is going to give you. Okay, I'm going to schedule you for 15.6 milliseconds. Boom, you're done. So the debugger goes to heroic effort to avoid this. I mean, when I first started doing multi-threaded programming for early versions of Windows NT, you literally bounced on every single step. So it's gotten a lot better. But this idea of they can't control all from the debugger, because if you've got this thread and it blocks, right, well, another thread goes on that CPU and X, Y, it looks to you like you bounced to another thread. Well, let me show you a little trick that is kind of cool in the debugger. If you know the name of the, if you are really interested in walking this thread, so I've double-clicked, made this the active thread, the 28 that thread, I want to finish out that thread. Or finish out that method, because I really want to concentrate on it. Well, here's a nice little trick you can do in the debugger. You can control-click all of these, then you can right-click and freeze. So what did that do? That froze all the other threads. So what are the odds of you jumping anywhere? 0, right? Because you just told the operating system, don't schedule these threads. I don't want them to execute. So this is a really cool thing because it gives you that control so we can finish out this method. Well, with great power comes great responsibility. Can you deadlock your application with this? Can you screw up your application with this little trick? Yes, you can. Right? But for me, it's the one thing that allows me to really see what's going to happen with this particular method, so I can debug it without stopping all of the bounces and everything else that goes on. So this is a very cool thing to be able to freeze. And of course, once you get down to the closing curly brace, what do you want to do? Well, you want to control-click all of these guys and do what? You want to right-click and thaw them. So that way, now they'll continue to run. So don't generally just run your application freezing and thawing threads to see what happens, but go use it to debug out. And I do this all the time. And so what I did is I've got in that Visual Studio commandlets here, I've got these disable non-active threads and resume non-active threads. So this disable non-active threads, what do you think that does? Well, if you execute that, that looks at all the threads. Oops, accidentally double-clicked there. And it says which one has the yellow arrow, that's the active thread, and calls freeze thread on all the other ones. And then when you're done, you're like, okay, I'm finished. What do you think that does? That thaws them all out. So it's a very cool way to gain control when you're doing multi-threaded debugging. So sure, the whole idea of setting the per instance ID and the freezing and thawing threads, you know, those are pretty cool little tricks, but wanted you to see that you could do all of this and do your multi-threaded debugging. And I thought it was a good thing to talk about, you know, since we're still talking about breakpoints. So we've covered a lot of good stuff here, and we've got more to go. So let's play around. So we've talked about, you know, our filter breakpoint. We've talked about our conditional. We have one other type of breakpoint that we want to play with, and that breakpoint type is an action, and that is a trace point. Ooh, turned into a diamond. Look at that, sexy diamond. And so the idea is that you've got a bunch of things that you can output here. Oops, I clicked the wrong thing. Let's get that up. I keep moving my mouse. Sorry. There we go. So you can see that we've got these special pseudo variables here, like $address, $function, and we can log messages out here. So it's like using the debugger to jam in a trace statement is basically what it is. So if I want to know how this got called, I can use a trace point here and do some pretty cool things with it. So for example, value of the this pointer, right? And I could, so there's my this equal, and anything I put in the curly braces will be evaluated, right? So that's going to show me the value of the this pointer. And I want to do, let's do the call stack. And notice I've got this set to continue execution, hence the diamond. So we're all set. And so basically we just jammed in a little trace statement there. And if we look at our output window, if I can find it, we'll go up here and you'll see there's my this pointer expanded out right there. And there's the call stack that led up to that. So this is just a way to jam in a trace statement on the fly. So it's kind of a nice thing and allows you to gain, you know, hey, who was doing what when this executed. Now if we go in here, oh, notice I accidentally cleared it. Here's the cool thing. I can press Control Z and it will come back. Yes, you can cheer for that. But if I want to stop execution, I can just turn it into a regular breakpoint, and that will keep my conditional with it, or my log message with it. But it will stop in the debugger. So let's tie all of these breakpoints together. So let's go back to our little loop here. Let me show you something pretty neat. So I've got this loop here, and I can go and set multiple conditions, right? I can say when I equal 3, and I can add a condition, and we'll do a hit count. So what is this? How does this work? Okay. So this is saying if I is equal to 3 and the hit count is 5. So think about that for a minute. What does that mean? This will be the 5th time I is equal to 3, because that's what we've specified, and it's an AND condition here. Okay? So we'll just prove this to you, right? So we'll do 1, 2, 3, 4, 5. That was the 5th time that breakpoint or that condition matched up, because we told it to do 2 conditions. So let me show you something kind of wild here. Okay? So I've got these breakpoints set. So I'm just going to go back to the 1 condition. Let's execute out. Now I'm going to set another breakpoint down below, and this one I'm going to set the hit count equal to 5. Okay, everybody, pretty straightforward. But now I'm going to go do something kind of interesting. I'm going to go over here to this location, right? And I'm going to change the line. So what did that just do? Well, let's go back and look at our breakpoints window. I'll clear out this other one. So, whoa, that's kind of interesting. Would you look at that? I've got 2 breakpoints on the same line. Right? Now, you see how I got there? Is that I went, and on that second breakpoint is I just click on this location and I changed it. Okay? Now, the UI doesn't handle this real well. I actually have 2 breakpoints here. Right? Just, oops, go to our breakpoint window so you can see it. Right? When I got the hit count is 5 and I is equal to 0, so let's, I don't want to delete that. Okay. So let's execute, and what does this turn into when I have 2 breakpoints on the same line? 1. Do you see it? When you have 2 breakpoints on the same line, it's an OR condition. So I wanted to mention this because this is a way that if you have to build up, your hypothesis is, I've got this really weird, really wild condition, and it's just too big to fit, and it's unreadable and not so understandable. I can always add it very simply. So let me clear out both of those breakpoints, right, which we just did there. I'm going to set this again just so you can, just to make sure everybody sees it. So we'll start with our standard, you know, whichever condition we want. I equal 3, okay, and then we go set a similar condition, or to whatever we want it to do afterwards, and I'm going to do hit count equal 5, but notice what I'm going to do is that little location right there, and I'm going to move that to line 37. Now I'm ORing my breakpoints, and then there's my 2 breakpoints on that line. Now the UI over here doesn't display it very well, right? See, because it just, whatever's first is the one it shows. But the breakpoints window will show it completely, okay? So that's just a neat little trick to be able to kind of gain control and, you know, really get serious with this, because these are now an OR condition on that line instead of the AND condition. Okay, so nice, cool little trick to see what was going on. Wow, we've talked for almost an hour just about breakpoints. Is that not crazy? Whew. I love my breakpoints. So what I want to turn to now, unless there's any questions, feel free to interrupt me at any point. I want to turn to our friend, the expression evaluator, because the expression evaluator is what you're using when you're talking to those breakpoints, and that the conditional operators, those are asking this thing called the expression evaluator. What does this mean? All right, you're normally used to things like the locals, the autos, the watch window. These are all expression evaluators. Even your good friend, the data tips, are a part of the expression evaluator. So all of these things talk to the same piece of code in the background. Anything that displays data talks to the expression evaluator. And, you know, so I want to show you something about this data tip. First off, I've noticed a lot of people don't realize this data tip is fully editable. Right? So you can edit the data all day long. And now another thing with the data tip, I've noticed a lot of people didn't realize, is notice right now it's on top of the code. So I guess I could move the mouse and lose the data tip, but this data tip's kind of cool, and I don't know how well it's going to show up on the live meeting here, but if you hold down the control key, it goes translucent, so you can see the code. And I've shown many people this, and they're like, oh my God, I didn't know I could do that. So I want to make sure that everybody sees that, okay, there's my code, there's my data, right? You can just press the control key to get this view. But this expression evaluator, the thing that displays data, right, all of these different views go to it, so it's pretty cool. And this expression evaluator has a lot of power with it. So let's go look at some of that power that's kind of surreal. So let's go, let me go set a breakpoint here. Oops. Mouse is jumping around. Go get some color bunch. Okay. So I'm going to set a breakpoint. Now let's talk about what you can do here. So I've got this method here called call a bunch. Let's go take a look at that method because it's a really exciting method. And here's our call a bunch method, and you can see what it does is it just bumps up a static and modulos 5 into it. But let me show you something kind of cool that this expression evaluator lets you do. So I'm going to go to my friend the watch window here. Notice I've got full IntelliSense. They want us to do this. So it's telling me that, well, there's my method. So how do I call this method? Hey, method, I put parentheses on it. Or if it takes parameters, I pass parameters. And all I got to do is press enter. And you can see that this code returns something, right? And we can also see in the output window, if I scroll down to the bottom, so it actually executed. Now here's the interesting thing, where did this execute, right? Was it the debugger, the debuggee, right, inside the debuggee itself, or was it Bill Gates' machine? Okay. Well, this executed in the debuggee, right, where the breakpoints default to executing in the debugger. A big reason why the diagnostic team changed that behavior was they got tons of support calls where people said, hey, you got to bug in the debugger. I type I=3 for a conditional breakpoint, my program breaks. Because they didn't realize they're changing the state. So they fixed that to not change the state in the breakpoints. But if you're smart enough to call something from this watch window, they're going to let you change the state. So think about that, because like, wow, I want to fill this data structure with a specific set of values so I can test. Knock yourselves out. The watch window lets you do that. Now, there's a limitation in the watch window, and that is 5 seconds, okay? And the other limitation is that, notice I've got a breakpoint set, we just need one, okay? So I'll clear this out. The other limitation, right, first limitation is 5 seconds. The second limitation, no breakpoints are enabled. So when you call this method, it doesn't enable any breakpoints. So call your methods, right? Get the state of the app the way you want to see it. But there's another place where you can call methods, and that's kind of interesting. It's our friend, the immediate window. And in the immediate window, it's just another form of watch window, but it's something you should pay attention to because, sure, I've still got my IntelliSense here. I've got my call a bunch. You have to put the semicolon on the end. When I press enter, what happens? Everybody see it? The breakpoints are not disabled, and you have an infinite timeout. So think about that for a moment. So if I want to really play with the program, I can do it from this immediate window. And the new immediate window in Visual Studio 2015 does full link statements and everything else. You can say this collection dot first dot greater than, whatever you want to do from a link statement standpoint, you can do it here. It's very powerful, right? Watch windows is the same way. I'm going to be calling a method. I want to go debug it. And we can tell that this method got called from the debugger when you go back and look at the call stack, and you see this evaluation of. So I can now, kind of just force execution into things and just play with state and kind of see what the state is. But I'm changing the state. So this is handing you a lot of power. It's very, very cool. Right? And when I press F5, what's that going to do? Well, another common question I get here is that people ask, what thread is this executing on? It's executing on whichever thread is active when you go hook in the threads window. So in this case, it happens to be the main thread is the only one that's running. That's the one that it runs on. Okay, so whatever thread is active. Now, when I pressed F5, what it did is it executed that method, then returned us to the breakpoint. So, so very cool because we've got this ability to gain that control over our execution. And I can try things. I can test my app. I always love it when I go onto a team and I see somebody's got test cases that say, go to this line in the source code, set a breakpoint, and then paste this into the immediate window. So you can get the state set to test this really weird condition. Don't be afraid to do that to get that really edge case, hard to hit scenarios controlled using the debugger. So that's pretty cool, right? So, but remember, the immediate window, infinite timeout, breakpoints work. If you do it from the watch window, though, 5-second timeout, and all breakpoints are disabled. Now, the other thing you see here is that the only time the watch window calls the method is when you first press enter. Notice it's grayed out now, because if the watch window kept calling this method, that could cause side effects city and cause a lot of problems. So they basically call it and then never call it again unless you click the refresh button, okay? And so we can click that again, and we can see that's the 4th time it's been called, because you see that, my call event here is just returning that static integer, and that static integer is 4. So it's pretty cool, right? We've got this great way to call methods. Excuse me. So we can call methods, we can gain control, and we can do big things with this. Now let's talk about another cool thing that this expression evaluator lets you do. So I'm going to press F5, and we'll continue to run. And I changed the way I code to take advantage of the expression evaluator. And the thing that's super cool here is that I can drag and drop whole statements down. And what I did is, if you look at the code I write, I never call methods in conditionals, right? I might call a property, but I never call methods. I always put them into local variables. Because why do I do that? So I can play with the results easier. So if I'm sitting here and go, what do I have to do to make this false? That's the data I need to go generate for this test case. So by putting everything into local variables, that gives me that control inside these if statements, so I can do things like I just did there. Now you're probably wondering, well, John, that makes the code, bloats the code. Well, no, it doesn't. Because what happens if you call a method inside this if statement here? Or do? The compiler creates a temporary variable and shoves it in. If you ever looked at IL-DASM or .NET Peak or the Redgate, oh gosh, I just forgot it. Any of those tools that decompile, had a brain cramp there, and they go down to IL, you might have noticed things that start with CS $. That means it's a temporary variable. So I'm actually not slowing down the code at all in there. Great, we got a couple
people shouting reflector at you there.
Reflector, thank you. Eves and Eric both get A's for the day. God, I had this. I'm like, what the hell is that name? So it's reflector. Thank you. In fact, I've got it on my machine. There it is. So crazy. So take advantage of this, right? Take advantage of this expression evaluator so you can gain control. Now you're looking at this, you're going, John, this is really, really cool, but I'm not working with static integers, right? So let's debug down a little more, and let's look at a more traditional case, okay? This case right here. So I've got this value 8, and so we can look at it, right? We're looking for the name field, and so you've all done things like this. Oh, okay, 80 is there, the name is not fixed, so here, I'll put my wife's name in. Okay, great, we fixed that. But you fix the individual fields here. But sometimes you need an entirely different object with a completely different state. Okay? So, how do we create objects in .NET? Well, last I checked, it was the new operator, right? So let's do, oh my gosh. It's by them putting IntelliSense in here, it's almost like they want me to do this. Oh my God, this is great. So I'll just press my tab, and we will say hi to Satya Nadella, the new CEO of Microsoft. So what am I doing here? I created a brand new object on the fly. Don't be afraid to do that, because you can sit here and create new objects in the debugger, and that allows you to gain control when you're debugging. Now, what happens if you have a little more interesting case than this, where, okay, wait a minute, I've got to create this object, but I've got to set its state by making this web service call or whatever it is. Well, guess what? Not only can you create objects in the watch window, you can create them in the immediate window. So I'm going to do something totally wild here. Notice, it's whenever they have IntelliSense, they want you to do this, folks. So I'm going to do an assert example, x equal, we'll say hi to Bill Gates again. So what did it look like I did? Well, not a whole lot, but if I type x in here and I display it, looks like I have a new variable, right? Well, let's go over to my locals window and tell me if you see anything kind of interesting. Wow. So I can go to the immediate window and actually create new local variables. Whoa. That's just totally bizarre. So I can go in here, I can sit and really use this debugger to test like crazy. It's amazing what we can do here. It just kind of, you know, I just played around with this and I found just the bizarrest things that you can do. So for example, I've got this simple Windows form map and it's got its main form here. In fact, let's just get freaky. Okay, y equal new, oops, accidental scroll lock there. So I just created a new form. Now, when you create objects in the immediate window, they don't come with IntelliSense, so you have to remember what's going on. Whoa, what did we just do? I just created a new main form from my main form and had it as a dialog. In fact, let's do debuggerception. Which one am I debugging? Right, because that's a breakpoint set. Well, if we go look at this call stack window here, I'm in the one that got created from the debugger. And think about this. You know, you have nearly a complete environment in this immediate window so that you can sit down and really play with your code. Right? This is really cool. Now, the one thing it doesn't offer, which is a little frustrating, doesn't handle conditionals, okay? But it does. I can never remember the order. Is it question mark? Oops. I think I can do this with a question mark. Is it? I think that one works, but we don't have conditionals. That's the one thing that would be really cool here. So I could then generate, you know, some information. But I want you to just realize the power of this, right? It's got full support for link here, and I can go create anything I want in my application, right? I've got this total control over this really cool ability to now test my code kind of this interactive way, almost like a REPL, right? Read, evaluate, print loop. We're real close to that here. My big wish would be if the new C# window, C# Interactive, would let us do this, but no, there's no hope. You can play with that, but you can't play with it from the debugger. So I was hoping that was going to do it, but you know, to hook that up to the debugger takes an incredible amount of work. So start creating objects in here. Use the debugger for testing here, because this expression evaluator has gotten better every release of Visual Studio. And I know it's on the list because I've asked for it. I've asked the diagnostic team, can you put conditionals inside this immediate window, or hook me up into the C# expression window so that I can now control my program and, you know, do things in there to look at state and everything else. So this is just a very, very cool thing. And, you know, I just love the fact that I can, you know, create objects on the fly, right? Okay, getting a good question here. Yeah, yes, you can. Lambda expressions are fully supported in the immediate window. Pretty much anything you can do in a lambda expression, you can do inside there. The only thing that is not supported are conditionals, like if, while. You know, but if it's the extension method, while that works as part of a lambda expression, but your standard branching statements don't work. Everything else works just fine. So it's just the if statement kind of thing that doesn't work. So play around in there. You know, I've created whole threads just to see what would happen. I've loaded up assemblies and called methods on them, right? Assembly.load from file. All of that is fully supported. So it's pretty neat, and especially from a testing standpoint. And with my job, where I'm in trying to figure out really weird esoteric bugs, I spend a lot of time in this immediate window trying to poke at the app to get it into the state that we're seeing on the server. Because most of the bugs I work on, we can't reproduce them in test. So we'll have to look on the server, we'll have to get an idea from the logging what's happening, and then we'll use the debugger to try to get it into that state. And it's proven very successful to find problems. So very cool stuff that we can create these objects on the fly. And it really opens up a lot of interesting debugging things. Now, the last thing I want to mention here is I want to get let's get another instance of Visual Studio running. Is I want to talk about something that almost never, most people don't know what it is, but it can be a very powerful way of debugging because, as you'll see here in a moment, when Visual Studio decides to start up, good, a question came in. Omid's got a real good question here, and I'm going to copy and paste. I don't know if everybody else can see it, but he was playing with the trigraph operator. So let's take a look at this. Oops, let me take that question mark off the end. Okay, let me break in. Wow. Wow. This is almost impossible to hit. I managed to break in the middle of a garbage collection. That's what that means. That is so awesome. The odds of that happening are between slim and none. So let me press F5 and we'll break in again.
Did you put your lottery numbers on for that?
Yeah, yeah, exactly. Buy the lottery numbers. Let me set some of these let me hit one of these breakpoints. We might be in a better spot. Wow, this is. I'm going to change it to trace.writeLine, because then we should see it. There you go. So yeah, this is what I was trying. I can never remember how to do the conditional operator, or the trigraph operator is the correct name of that. But that does work. So you can't so Omid's question is comment is a real good one, and I'd encourage you to go to the QA manager and copy out what he's done there, because I've written tests that say start the debugger, go to this method, set a breakpoint, then go paste this into the immediate window, and at least this way you can get some conditional operation going on it. That's about the only way that works. But if all of us ask enough on user voice to get get if statements in here, that would be really good. That would be fantastic. All right, great question, Omid. So let's look at one other thing, and we'll open it up for general questions. I'm going to open up a fun little program that took me many hours to write, so I hope you appreciate it. Okay. It's a real exciting program. I'm warning you. So what we've got here is I want to show you something pretty interesting, okay? So I've initialized this pointer and this SV value. So let's right-click here, and notice we can add this to the watch window. We can add it to the parallel watch, so it, all threads, it'll look for it. It's kind of a cool window. But we have this make object ID. Have any of you ever looked at the documentation for make object ID? The documentation says this: make object ID allows you to put an ID on the object. Wow, that's really helpful, isn't it? Well, if I click this, look at that, $1. And you see it in the locals window now. And I can go back to the watch window and I can type $1. And you're like, wow, John, what is the point? Well, the thing I want you to realize about this is that this allows you to put an observation on an object, has nothing to do with reference counting, nothing at all. This is a trick in the debugger that's supported by the CLR debugging API that says, watch this object in memory. Okay, so put that observation on it. Now, this program was written to show you something very interesting. So if the hypothesis is that your code this object should be garbage collected by this point, what happens? If your object ID is null, you know that the object got garbage collected. This is the only way I know inside Visual Studio where you can look to see that something got garbage collected. Now remember, what's the rule of the garbage collector? It's non-deterministic. The garbage collector runs when it feels like it. In fact, calling gc.collect, it may just get into the gc.collect code and go, ha ha, not run at all. So there's nothing stopping you, because I showed you how to call methods down here. You can try to call gc.collect yourself, right? But it may not work. But this is a way with this object ID that I can watch an object and see when it got garbage collected. When it returns null, I know the object has been released from memory. So this is not something you need every day, but when you need this, you need it pretty bad. And another thing that this allows us to do is that it allows us to do, I'm back in the original program, the other instance of Visual Studio. If I go look at my locals here, so I'm going to right-click here and say Make Object ID. That puts that ID on the object, but how do I break on a per instance object without changing the code? Well, with that object ID, I can now go to the condition, and I can do that right there, because I've got the object ID on it. So it allows me to break on a per instance scenario here. So we'll run, and there's where this is equal to the object ID. So by letting us do per instance breakpoints without changing the code, because we've assigned it the object ID, and observing an object as it moves through the garbage collected system, that's why make object ID is pretty darn powerful. Okay? And so start taking advantage of this to kind of observe your objects. In fact, now that we're talking about memory, another very common question I get is, how can I tell what generation an object is in? Well, I showed you how to call methods from the watch window. Well, the GC class, you guys should all have this memorized because it's a pretty important class. The GC class is a whole bunch of statics, and it's got this really cool method on it called getGeneration. And if you want to look to see what generation your object is in, that's all you have to do. And so anytime you want to, you can call gc.getGeneration, because if your hypothesis is this should be a short-lived object, it should never be up into generation 1 or 2, and it is, well, if something's holding on to it, you've got a potential memory leak. In fact, the object ID can even be passed here. So if you put an object ID on this object and it's in a completely different thread, you can still monitor it. That's what's beautiful about make object ID, is that you get to see that object no matter where you are in the program. Well, excellent. So we got to talk about a lot of really good stuff here, right? We talked about setting location breakpoints, where we set breakpoints in the call stack window. We did sub-expression breakpoints. We quickly breaking on any method with our good friend debug, new breakpoint, break it function, or control B. And I love how they fixed the keystroke on the general settings. That's now controlled. It was something different with the RTM, but with update 1, they fixed that. Here we talked about all of the location breakpoint modifiers, where we can set all of those conditions. Oops. Let's do. Oh, that's a bug. Oh, there it goes. Okay. We've talked about all these conditions that you can do. The hit count. Right? Remember, the importance of that is that it always has a counter with it. We talked about the conditional expression and remember, the conditional expression can only hit and read memory by default, but if you turn on the manage compatibility debugging mode, you can actually change memory. We also talked about the filter. We talked about ways of creating filters so that we can narrow down to just what a particular thread is running. We talked about some of the multi-threaded debugging tricks of freezing and thawing threads. We talked about renaming threads. We talked about the action where we can apply a trace statement on the fly. We also talked about changing the data, right? Creating new objects on the fly, creating new objects inside the watch window and the immediate window, calling methods from the immediate window and the watch window. And finally, we talked about make object ID, where we can get a nice way to monitor a piece of memory no matter where we are in the program as that piece of memory moves through the garbage collected system. So, a lot of stuff in almost an hour and a half. So at this point, I thank you very much for attending. Let's just throw it open for questions. Does anybody have any questions? And remember, I'll handle any kind of questions except relationship issues. It always works for me. Hey, thanks, Jag. I appreciate it. Just email me, and I'll send you my little test program because it's not really exciting. But Jag is asking for the test program. I'll be happy to give you CS breakpoints in all its glory, so you can play with it on your own. Nothing really proprietary in there.
I have to say, it was very impressive that you caught the break on me during garbage collection.
Yeah, that is just, like in all of my debugging at .NET, I think I've only seen that one other time in Visual Studio and only once in production where we're trying to take a mini dump. We took a mini dump. Bazad has got a good question here. Is there an indicator in the thread window to show if a thread is frozen or thawed? Yeah, let me get this going again, and let's break in. Yeah, so Bazad, if a thread is frozen, you're going to look in the second column here, and you'll see that pause. That little pause button right there. That's what indicates whether it's frozen or not. If it's cleared, it's an active thread. Okay, so that's a good question. Wyatt asked a good question. What do I think of C# Interactive? I think it's pretty cool, especially with what they've done in Update 2. Because in Update 2, you can right-click here and initialize interactive with the project, and that will basically load all of your assemblies in the interactive window, so you can start playing around and like doing prototyping and stuff. And I've been doing some analyzers, which you can also find up at our GitHub site. Wintellect analyzers. So these are just a collection of really cool analyzers that I've written here with Jeffrey Richter and I, and trying to figure out Rosalind. I use the interactive window to play around and say, well, what if I call this? What if I call that? So I found it very good for, I've been very happy with it, playing around with it just to kind of see how APIs work. And the one thing I wish it had is that it had that hook into the debugger so I could write code that talked to the debugger and, gave me conditionals and things like that. But I think it's, if you've ever played with PowerShell or Ruby or F# or any of these interactive type languages, it really opens up a lot of neat things. And I think C# Interactive is a great step in the right direction. And I'm expecting a lot out of the next version of Visual Studio. Yeah, so Adam Hearn says that the PowerShell wrappers for the macro is excellent. Yeah, Adam, that was pure unadulterated pissed offness on my part. I still can't believe that Visual Studio does not have macros. It's just annoys the hell out of me because I don't want to write an add-in to do something relatively simple. So I just was pissed off. Hey, before everybody goes, remember, you can go to Wintellect now, and if you use the code JohnR26-2016, you can get 2 weeks free. So you can watch this presentation again, and you can watch a whole bunch of stuff on Debugging and SOS, for example, because that's a lot of the work I actually do, is spend my days looking at mini dumps off production servers, trying to figure out where the problems are. So you'll see my whole session on that as well. I got a bunch of stuff on native debugging as well, if anyone is still doing that.
Great stuff, great stuff. So while with any more questions coming there, John, I just want to say thank you very much for your time.
Oh, thank you guys for attending. I appreciate the opportunity.
It's always a pleasure, especially when a lot of people from the community like yourselves will give the time for things like this. I always find when you learn more about any topic, I said quite recently I did a big deep dive into the garbage collector, but it just makes you hungry to learn more. But it's always a pleasure just to listen to people talking.
That's good that you were doing that, because I've always maintained that if more people knew about how the garbage collector worked, and how long did it take you to figure it out? Like a couple hours, start to finish? If you knew how the garbage collector worked, you would stand a much better chance of solving a lot of production problems before they ever became production problems. Because that's the big weakness I see, is that a lot of people are like, I don't know what's happening with memory, and they don't have that conceptual model in their head. And, well, actually, I should say don't learn about the garbage collector, because I make a lot of money because people don't know.
That's one way to look at it, I suppose.
Wait, I'm screwing myself here. No, don't learn the garbage collector.
Oh, yeah, going about, especially the debugger garbage collection, it just changes the way you do things just completely. You're a different person after it.
Oh, yeah. I've always been, I've been developing in Windows for a very long time. And I was telling somebody the other day, like native code and C++ code performance tuning, how I do that? I print the code out and then turn it face down on a conference table, and I can feel the performance problems because I just know exactly what native code is doing. In .NET, even after doing it for almost 20 years, I'm just now understanding it. Yeah. It's a very different beast. Very different beast than anything you deal with on a normal basis, because it does a lot of things for you, and so you have to account for that.
Yeah, definitely. I think that's all for questions now. So if you're good, John, we'll close there.
Yep. And if anybody's got any questions later, there's my contact information on the screen. So I look forward to your questions.
Thanks everybody for attending. And again, thank you very much, John, for your time. And just before we go, I just want to say thank you again for our sponsors. Without you, we can't do what we do. We've got Wintellect now, Pluralsight, Inner Workings, AuxWeb, Telerik, SyncFusion. Thank you to you guys. And thank you again for everybody who attended. Thank you very much.